right, let's take the second IP, the meta-level representation one. I think that's kind of interesting. Marshall, would you give us a little thumbnail sketch on this? So
label and the arrow in there's
I think that the cursors are marked.
Ah,
so in the upper one,
okay.
this is user one's
Okay.
cursor, and then the other one is
I
user
see.
two's cursor,
I
and
better
then in the
make a note of
lower
that.
image, it's user one.
Tivoli is an interactive whiteboard tool. It was designed to support meetings with an electronic board, such as the Xerox Live board. Tivoli allows free-form scribbling with a pen. The user can edit material on the board by gesturing with a pen to accomplish such tasks as erasing, moving, shrinking, or coloring. Tivoli also maintains the implicit structure of items in lists by opening and closing spaces as necessary. Material on the board can be organized into regions by drawing borders. The user can edit within a region and move material between regions. Tivoli allows flexible and fluid whiteboard use. This is crucial for following the rapid flow of meetings. Let's look at an actual meeting. The purpose of this meeting was to take items from 4 previous meetings and pick a few for further study. What we're seeing is 1 hour of whiteboard activity compressed into half a minute. There's scribbling on the board, of course. But the main board activity is moving items around to discover a useful categorization scheme. These items are the primary subject matter of the meeting. Domain objects were designed to represent this kind of subject matter. They are integrated into Tivoli's whiteboard environment. Domain objects are defined in a scripting language in Tivoli. There are classes and instances, such as items A, B, and C. Domain objects are displayed in different views, such as a small view and a full view. Rules specify how domain objects react to gestures, such as by changing their views or their values. The values of domain objects can be dynamically computed by specifying spatial formulas, such as in a class of adders. A page adder sums the costs of all items on the page. A local adder sums only the costs in its local region. Regions are defined not only by straight borders, but also by free-form enclosures. A linked adder sums the costs of items that are linked to it. Let's look at how these features can be used to create tools to support specific kinds of meetings. Here's a budget meeting. 3 budget centers must trim costs in order to get out of the red. Costs can be adjusted. A border can delimit the spending regions. Items can then be moved until the budget targets are reached. Here's a decision-making meeting. Many projects have been proposed, but only a couple can be funded. Information about each project can be retrieved to review it. Scribbled annotations can be made. Projects can be rearranged. If a vote needs to be taken, vote objects can be created. Votes are ticked off as they're cast. And the projects can be sorted by vote. Finally, specific projects can be selected. Timing is often critical in meetings. Here's a meeting where conference submissions are being decided upon. As submissions are accepted and rejected, a tally is automatically kept. A clock object also runs. So timings can be computed to dynamically predict how long the meeting will take. Tivoli has been customized to support the intellectual property review meetings at Park. These review meetings occur in a larger context of document work practices. Intellectual property is stored in a Lotus Notes database, where individuals can access it. Invention proposals are entered into the database as they're created. Before a review meeting, a script is run to export the information needed for that meeting. This is combined with domain object definitions that provide a customized set of tools for the review meetings. The resulting set of Tivoli pages supports the meeting. Let's look at an example from an actual review meeting. The first page shows potential attendees. Tapping on person objects marks them as present. If there's an unexpected attendee, a new person object can be created with a scribbled name. The next page holds the agenda, which is the set of invention proposals to be reviewed. The material you'll be seeing is disguised. The agenda can be reorganized. Gesturing on an invention proposal jumps to a page for recording the assessment of that proposal. The proposal is discussed around the table, where a laptop is used to take notes. As notes are taken, they're beamed into the notes region on the board. After the discussion ends, attention is turned to the board, where action items are scribbled. Each action item is made into an object, which can be opened up and a person assigned to it. Assigning a rating code sums up the evaluation of the proposal. After a new invention proposal has been evaluated, it must be ranked with previous invention proposals in a priority list called a ladder. Previous proposals might not be remembered, so they can be opened up and reviewed. The new invention proposal is then moved to a place in the priority list. At the end of the meeting, all the action items created can be seen next to the people they're assigned to. They can be reviewed and revised, and they can be reassigned. The work of the meeting, the decisions, the commentary, and the action items can be incorporated back into the workbase. Tivoli provides facilities to customize meeting tools that can be finely tuned to the practices of particular types of meetings. And at Park, in fact, we've been using these tools to support our own meetings for several years.